Okay, thank you for joining me today. Today I'm going to talk about responding to change and uncertainty. My name is Zach Neese. I am Chief Technologist at Rally Software. Also, I'm part of the faculty at the University of Colorado, where I teach entrepreneurship in the engineering school. But at Rally, I have the unique opportunity where I get to go around and talk to our customers, see what's going on in the marketplace, and really look and understand what's 1 to 3 to 5 years out in the industry. Today I'm going to talk about the fact that the biggest risk you face in your business is changing. And that risk is failing to respond to market shifts. Now you may be thinking, what, another risk? You've got all these things you're already paying attention to. You've got schedule risk, you've got business risk, you've got execution risk. Well, I'm going to tell you there's one emerging that could trump them all for your business, and we'll go into more details about that here in a minute. First, I want to start out by an example, kind of set the stage for a real company that's went through this. So this is a local consumer data company, and what's missing on this chart is about 5 years where they held 80% market share of their market. But what I'm showing here is this is their web property, their web application. Yellow indicates desktop usage, and the blue or teal indicates mobile usage. And a lot of the mobile could be phone or iPad. But what you see here is they started to see this trend where their traditional 80% market share was all in the desktop, started to show up in mobile. About a quarter or two after that, they realized, wow, we're really getting a spike in mobile usage. We probably ought to show up on the mobile desktop, show up on the devices, the iPad, the iPhone. So this is the first point where they recognized as a business, hey, we need to respond to this. A quarter later, they begin the specification process. So this isn't a particularly agile company. They're sort of agile, but they struggle a little bit with this. So they begin the specification. A quarter later, a startup competitor shows up and ships their 1.0 on iPhone and Android. So that's their first entry into the marketplace. Now you see for the bigger company here, it's continued slide of usage onto the mobile side. Quarter later, because they're a startup, the competitor ships their 1.1, shows up on the App Store, gets great reviews, lots of usage. Now the company starts to see a dip in their overall market share. Finally, a year after they recognize this business threat, they've now got the mobile app defined and they begin development on it. Startup competitor now ships their third major version, their 1.2 version, a quarter later. We can see what's happening in the marketplace. And then a year after development begins, they ship on iPad, iOS, and Android. And the executives look back and say, wow, in that 1 year, we forever lost half of our market share. Gone forever. And that's gut-wrenching if you're a technology executive and you watch that happen. You identified the business risk over a year ago, and you lost half your market share just getting to that point. So what's going on here? What are the dynamics at play? I think what's happening is that the time needed to change these fundamental market expectations are changing. Let's look at some examples here. Back in 1984, Apple released the original Macintosh. And in 2006, it's really when this all-in-one unit really set the market pace for what to expect out of a computer. Our developers were using this, my grandmother had one, really changed the expectation of an all-in-one computer. That took about 20 years to accomplish. The iPhone, released in 2007, by 2010, fundamentally changed what was expected of what you could hold in the palm of your hand. That took 3 years. 2010, the iPad was released. In 2012, the iPad 3 was released. In just 2 short years, fundamental expectations were changed around what it means to have mobile computing. You don't go for your laptop anymore at home. You go for your iPad. Now let's look in the social networking space. 1979, CompuServe came out on the marketplace as a way for people to connect online. By 1989, they had really fundamentally changed the market expectation of what that means. So it took them about 10 years to do that. LinkedIn accomplished the same thing in the professional networking space in 5 years. Yammer, inside corporate firewalls, accomplished the same thing in 2.5 years. And Instagram in the consumer space fundamentally changed expectations in just 1.5 years. What this is called a big bang technology disruption. The amplitude of the changes are much greater, and the time is getting really compressed. The other really important thing to note here is Jeffrey Moore talked about crossing the chasm, where new technology gets stuck in the chasm. With these types of disruptions, that chasm has gone away. Big companies used to play the game where they'd watch a technology go into the chasm and wait till it started to emerge from that before they responded. You don't have that ability anymore. So huge market shifts and changes in the dynamics and expectations of your market can happen in a short year. And it really begs the question, are you agile enough to balance these two risks, the risk of operating your business and continuing to produce your sustaining products, as well as responding to these market changes? So a typical approach to this is creating a business plan. How many folks here have created a business plan? Yeah, most of us. Usually it goes like this. You do a bunch of market research, project definition, you get down into the requirements, detailed planning, you go into the development, you get the user acceptance testing, and then the final release. Well, how many guesses did you make about that, especially if you're in a changing environment? And then you have first contact with actual users if you use this approach. And it usually goes something like this. First contact of all of those guesses in one big batch, coming into contact with those users. Just because we can, let's see this from another angle here. Notice that chin, the steering wheel hitting you in the chin. That's that moment you realize, oh no, we have built something no one wants in the marketplace. Or it's taken us so long, the market has totally shifted while we've been doing that. Many folks here have done that, a product release like that. Yeah, I know I've done several in my career. The problem with that type of planning is it obscures all that uncertainty with details of a false precision. What we need is a method to embrace all that uncertainty and reveal it and then systematically mitigate that uncertainty. So why does this feel unnatural to us? I think it actually stems back to about 100 years ago. Fred Taylor wrote this essay about the principles of scientific management. And it really heralded this whole way of managing people and really got great efficiencies in the industrial age. And the fundamental idea is that it was all about getting individuals to the highest state of individual efficiency. And that's when they're turning out their largest daily output. The problem is, for our context today, is he was talking about men moving pig iron, lathing metal, and women and school children inspecting ball bearings. This has fundamentally changed over 100 years. And this assumes that certainty is high and maximizing individual efficiency is what you want to do. That's what this was designed for. 100 years later, that shows up in our current business management as status quo budgeting, comprehensive analysis, detailed plans, and waterfall execution. Now this works when certainty is high. But how many of you think that your business is getting more certain every day? Probably not many of you. So what we need is an approach that embraces agile execution as well as lean thinking to balance that execution and exploration. Now this is a method that assumes uncertainty exists, and the goal is to maximize the value delivered in uncertain environments. So instead of this status quo budgeting, we talk about adaptive steering. Instead of this comprehensive analysis, we do disciplined exploration. Instead of detailed planning, we do empirical learning. Instead of waterfall execution, we do agile execution. Now I want to zoom in on this empirical learning because no matter what state you're in, no matter what product you're doing, this can help you mitigate the uncertainties you face. And our goal here is we want to turn all this uncertainty into knowledge. Knowledge about what the market wants and what's going to be effective in the marketplace. How many people here have done a science fair project or helped your kids with a science fair project? Great. You all know how to do this then, because this is based on the scientific method. The idea here is that we go through a preparation phase, and then we go into experimentation. The preparation starts with a lightweight canvas instead of a business plan. This can be a business canvas if your primary risk and uncertainty is in your business model, or an initiative canvas if your primary uncertainty is in what you're going to build. You fill out that initiative canvas. I'll use that as an example. Sticky notes, it doesn't feel precious. It invites change. It invites that you're going to work on this and fundamentally change it. You do this collaboratively. After you've done the initiative canvas, then you enumerate all the assumptions and risks that you're making inside of there. You reveal them. You celebrate them. You rank those assumptions. You figure out what your key assumptions are. And then the idea is you run multiple experiments on each assumption to turn that key assumption into knowledge. And it's critical to run multiple experiments here. And when we go through and run experiments, I think, Lean Startup talks about build, measure, learn. I think there's a really critical piece of that that's missing, which is called frame. So I talk about frame, build, measure, learn. And what we want to do is frame the problem and frame the experiments. And these two simple sheets, and I'll show you where you can download them here in a minute, can really go a long way to help you frame the problem and frame the experiment to make sure you maximize your learning. Now, Einstein said the formation of a problem is often more essential than its solution. Getting the problem right is really critical. Now, this seems unnatural to us because if you had an undergraduate engineering degree, you were probably given 5,000 problems to solve during that education. And there was one right solution, and the game was find that one solution. But in business, it's all about finding the right problem, not the right solution. And finding that right problem starts by interviewing. You have to actually sit down and interview and talk to people and build empathy. So figure out what they're saying about their problems, what they're thinking about them. If you observe them actually doing something, what are they doing? And really importantly, how do they feel about that? What are their motivations, their tensions, their anxieties? And under what circumstances do they experience these? Once you have that, then you aggregate these and you look back and you seek insights from the data. Now, the way this works is that our brains have what are called mirror neurons in them. And if you look at somebody having a direct experience in a PET scanner and somebody else watching them, our brains fire almost in the same way. So you combine that empathy with your own insights, and that creates a framed problem. So an example of this is some Stanford students went to a design challenge where they were trying to figure out how to make more affordable incubators for babies dying in Nepal. The problem was there are babies dying in Nepal. Go figure it out. They thought it was all about the incubator. They go to the hospital. The first thing they see is a wall full of empty incubators that are perfectly functional. And they're like, well, what's up with that? And the doctor said, well, these incubators are fine. The actual problem is the babies never actually make it here. They die out away from the hospital. So they reframed the problem and realized what they needed is not a cheaper incubator in the hospital. They needed a way to keep the babies warm out away from the hospital. So this device here almost looked like a sleeping bag, has saved 300,000 babies. So that's the power of framing the right problem. The next piece is you want to frame the experiment. You want to actually write down, what are you trying to learn and why? What's your hypothesis? What are you going to use to make this happen, and what variables and measures are you going to measure? There's a really important thing to think about here too. If you experience the corporate white blood cells, the corporate immune system, when you try to do something a little bit non-standard, this is really important because you want to be able to run experiments that are safe to run and keep that immune system off of you. So there's a good way here to articulate that to keep that away from you. So once you frame the experiment, then you go through building. And this is your classic. You can use Kanban or Scrum as a tactic here to do the building part. Then comes measurement. Because without measurement, you won't be able to reflect back on the data. So the first thing, just like in your science fair experiment, is you collect the data. And a lot of people, when they build software or build projects, they don't build in the capacity to collect data. So don't skip that as you're designing your backlog. The next thing you need to do is analyze that data, because you need to turn that raw data into information, and then you need to organize the data. That way you can actually tell a story about what you learned. Then the final piece is learning. Daniel Kahneman, a brilliant psychologist on bias, says hindsight bias makes surprises vanish. What does he mean by this? Well, learning is what happens between what we expect will happen and what actually happens. Learning lives in the middle of that. And we frame the experiment, that way we can actually reflect back on it and learn from it, because hindsight bias will rob us of that. We'll get a result and we'll think, yeah, of course I expected that result. And in that, you'll miss that opportunity to learn. Once you get your results, then you frame on the other side of this sheet here. So this is the prep side, and then you get all the results here. What were the results? What did you actually learn from it? Ancillary insights, because often you learn more accidentally than you do intentionally. What next steps do you want to follow? And then a way to summarize it, including down here, there's a really important piece where you record cycle time and how much money did you spend gaining that knowledge. Let's look at an example here. let's say you release a feature, you run an experiment, and you have a hypothesis that 25% of the users will adopt this within a month. You run the experiment. Now let's assume you didn't actually write that down. You look at the data and 55% take it up. And you think, oh, that's fantastic. That's so much better. That's awesome. Well, if you didn't write down the 25%, your brain's going to say, yeah, we expected about 50% to take that up. And you're going to miss that opportunity to learn why in the world did you get twice the uptake than you thought? What is going on here? Because even if you get good results, you still need to learn from them. So that's the empirical learning loop, the way that we can take all this uncertainty and systematically turn it into knowledge. The key thing to keep in mind is you maximize your ability to learn when 50% of the time you get an unexpected result. Now, if you're always getting the results you expect, that's generally a safety issue. People are afraid to admit that they're going to get an unexpected result. And if you always get unexpected results, that means you need to do more empathy work. You need to talk to people more and really understand what's going on in their world to more effectively run experiments. So now I want to turn it over to advice from a master here. Richard Feynman's one of my intellectual heroes. Turns out he's actually pretty good, or was pretty good at the scientific method. So let's hear from him about what he thinks the scientific method's all about.
Now I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we well, don't laugh, that's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature. Or we say compare to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. In that simple statement is the key to science. It doesn't make a difference how beautiful your guess is, it doesn't make a difference how smart you are who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.
So Richard Feynman has some important insights there, even in corporate America. In academia, he said, if there's somebody famous who suggests something, but it doesn't match up with experimental results, then it's wrong. So that's the same thing that happens in corporate America or in your company. If a CEO says, this is the reality, this is true, the experimental method will say, if it doesn't check up to the results, then it's not true. It's an unexpected result. You need to learn from that and move on. There's one last thing to keep in mind here that I think is really important, because most of the uncertainty we face is in the human interactions, because we're building software for people, and people are non-deterministic. It's that technology adoption is a human phenomenon. I think it's really important to keep this in mind as we're going through these techniques. So I want to show you a quick example of this. In this clip, the music is the technology being adopted. This is from the Sasquatch Music Festival a few years ago. So what we have here is a lone innovator dancing to this music. So he's adopting this technology. And if you look at him, the people are kind of walking past him, looking at him like he's completely crazy. If you listen to this with headphones, you can hear people making fun of him. And then suddenly another lone innovator shows up and starts to adopt this technology. Now, if you look at this, they're not actually particularly good at adopting this technology. And they're kind of out there alone, just in their own little goofy space. So I don't know about you, but how does this make you feel right now? Do you feel a little awkward for them? And anybody who's pushed new technology or new process into an organization, you were the lone innovator, you probably felt like these two guys did. And now we have a third person jump in, another crazy early adopter of this technology. And again, not particularly good at adopting this technology. Now, pay attention here to how long these guys have been out here dancing. Quite a while, awkwardly long. And now suddenly, the group is doubled instantly. Now it's doubled again instantly. And suddenly now those lone innovators, you can't even see them anymore. And this is now the early majority showing up. Where people saying, hey, this doesn't look so scary, there's people like me there. And now people are running in. We've crossed the chasm here, and now sort of the pragmatic people that just enjoy dancing and music are showing up. And then there's a really important part in technology adoption, which is Jeffrey Moore coined the phrase the tornado. In this analogy, it's the point where what's more awkward, standing up and dancing or sitting down on the grass? And when that balance is passed and everybody dives in, it becomes more awkward to stay with the status quo, and that's when everybody starts rushing in. So now if you do the math, we have 50 people now rushing in, when before, the same time period, you'd maybe have one coming in. Now what's also deceiving is this is the point where for companies and technologies, you start getting the press releases. You get companies going public, you get all the attention, and it looks like just out of nowhere, this herd appears and everybody's adopting the technology. But it's important to remember those lone 3 people are out there for about a third of the time period of this video. And those are the early people when you're building something new, figuring out what they want and figuring out what's going to take it from 3 to 300. That's where a lot of the uncertainty lives. So this happens in music, this happens in technology. It was first documented in seed corn in the 1930s. This is a human phenomenon. We may be makers, we may be building technology and think it's all about the technology, but the reality is it's all about the people. And that's why we need a human-centered approach to this. So I encourage you to think about the agile execution techniques, the lean thinking, and the human-centered ways we can make connections with people to learn it and understand what's going to get them from a crazy, wacky innovator out there adopting something new to a whole tribe of passionate people. And I encourage you to think about using the experimental method, that disciplined exploration, to help balance your execution as well as your exploration around that uncertainty. If you'd like to learn more, you can go to rallydev.com/ELS. You can see our full kind of information around all of our tools here for disciplined exploration. And if you want to download these 2 sheets of paper, go to rallydev.com/frame. You can follow me at Zach Neese on Twitter. I already posted the slides.